Yeah,
All right. So we talked about implicit the other day. So implicit occurs when you cannot separate x and y's. Now this function is actually explicit, but it is easier to do as an implicit function. Because explicitly you would raise something to the fourth root, or 1/4 root rather. So like no one wants to do that. So taking our derivative, now when we take these, we add back in that notation of d dx. So the derivative of x to the fourth becomes 4x cubed. But now we're deriving variable x with respect to x. So you add that dx dx. Then we take the next term's derivative, which would be 4y cubed. But we're deriving y, so we have dy, with respect to x. So we get dy dx. The derivative of a constant is 0. Solve for dy dx. So in order to solve, remember dx dx is 1. We're going to subtract 4x cubed. We get 4y cubed dy dx equals negative 4x cubed. Divide by 4y cubed. And we get dy dx equals negative x cubed over y cubed. So again, that represents the rate of change to the outer edge of that object. So that seems simple enough. However, the directions say find the second derivative. So we're going to do it again. So, second derivative is d2y dx squared. So again, it stands for the second derivative of y with respect to x. So now this is a quotient rule. So it's denominator, home, di, derivative of the numerator.
Wait, I just get rid of the fours. Oh, I'm so crazy.
So, ho, di, minus hi, d ho. So derivative of y cubed is 3y squared. Again, we took the derivative of y with respect to x. So it's dy dx. All over denominator squared. Yeah.
There's no such thing as dy over dy, right? It's always dy.
It could be dy over dy if we were deriving with respect to y, not x. So then when you took the derivative of x, it would be dx dy. Okay? Clean it up algebraically. So you get negative 3x y cubed. Dx dx becomes 1. We have a negative times a negative, so you get a positive 3y squared x cubed dy dx all over y to the 6. What's happening in this derivative that probably or just really doesn't look like what we're used to? Yeah, so we have x and y's together. But what about this right here? Do we normally have that dy dx kind of floating with our variables? And there's really not a good way to isolate it. But what do we know about dy dx? Yeah, we know what it equals. Observation. So we're going to replace this with that.
Dirty job. No boy job.
Here's where your algebra plays a huge part. We have y squared in the top, y cubed in the bottom. So we're going to take those two away, cancel them with that one, and that just leaves me with a y in my bottom. We're also going to multiply my like x's together, add their exponents, and this negative is going to come back out in front. So you get negative 3x squared y cubed minus 3x to the 6 over y all over y to the 6. What's the big no-no that's happening now?
A fraction within a fraction.
So what can I do to try to get rid of that problem? What do I need to have happen between these two terms? Yeah, I need a common denominator. Yep, so we're going to multiply by y over y. When you do that, it's like the h's. Remember when you had like the denominators and they went up into the h's? That's going to make this negative 3x squared y cubed. Actually, sorry, y to the 4th minus 3x to the 6th all over a y, but that's over y to the 6th. So what can I do to these? Yeah, it's going to become y to the 7, because that's like 1 over y to the 6th, 1 over y to the 6th, so those go away, and then you can multiply your denominators. So I didn't do this on Monday. What can I take out of these two problems?
X squared, 3x squared, negative 3x squared.
Josh, you're always right.
I'm running out. I'm in the
I'm
corner right now.
Okay. What does that leave behind?
Y to the 4th plus 2, or no, x to the 4th, wow.
We'll be in a second.
I don't like that this is originally this answer.
What?
We start with x to the 4th, y to the 4th, and we end with x to the 4th.
Yeah, because do you know what I'm going to do to that x to the 4th, y to the 4th? To make it,
Make it 16.
quote unquote, yeah. We're going to plug 16 in here and get rid of this.
Dang.
More subbing.
I need to draw an arrow. Oh, got home.
So you get negative 3,
I need to draw a couple.
16 x squared over y to the 7th. So we get this beautiful, simple negative 48 x squared over y to the 7th. Nice, pretty, concise.
That's what you're calculating.